Okay, so today we're going to be talking about sine, cosine, and the unit circle and how these are all interrelated. Really understanding sine and cosine will come down to understanding the unit circle and how it operates. So we're kind of going to start with the unit circle and move forward with that. You've encountered this concept before, but maybe you've forgotten a couple things along the way. So let's start with this. First of all, when we're talking about the unit circle, we are talking about kind of your standard coordinate plane. Unit means we're talking about radius is 1, and then of course it's a circle. And also we have to remember that this is centered at the origin. That's what the unit circle is. It's a circle of radius 1 that's centered at the origin. And that's going to be a big deal as we go through some stuff today. So I'm just going to make a brief diagram here. Try to make a unit circle that's relatively circular. And after this, you'll know why I have so much grace for you not being able to draw perfect circles either. All right. So we'll pretend this is our unit circle. The radius is 1. And we are going to measure our angles along this circle, starting at this point in the circle, so out to the right, and going counterclockwise. That's how angles are measured when we're talking about the unit circle. So this angle right here, oftentimes we'll use the Greek symbol theta, T-H-E-T-A, to represent the angle. And that angle can obviously be anything. It can go all the way around to over here in the first, so it can go through the first, second, third, fourth quadrant. It could even be something where it wraps around. I'll use a black one. Where it wraps around and comes back and stops here. That would be an angle that's greater than 360 degrees. So to pare this down a little bit, this is 0 degrees out here. This up here would be 90 degrees. This is 180. This is 270. And if we got all the way around once, then this would be considered to be 360 degrees. All right, so this is just kind of helping to get your bearings. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. And again, this is just showing you what the unit circle is, how we measure angles within the unit circle, and then where each of those angles lie. All right. So now that we kind of have that basis for what a unit circle is, we're going to talk about how it's connected to sine and cosine. One of the biggest things, the most helpful things you're going to have here is that sine of your angle in a unit circle is going to equal your x-coordinate. Not true. Sine is your y-coordinate. Sorry about that. And cosine is your x-coordinate. Okay, sine is y-coordinate, cosine is x-coordinate. And so what we're going to do is I'm going to redraw a unit circle, and we're going to talk about why it works out this way. All right, so just give me a second to redraw this. Okay, so again, we're going to pretend this is our unit circle. And we're going to pretend we have an angle here. We'll call it theta. Okay, so what we're going to do is we're going to turn this into a triangle, a right triangle, right there. Okay, now let's go back to this thing that you've learned before. Most likely. SOHCAHTOA. This is a mnemonic device, which is a memory helping device, which is supposed to help you remember that for sine, you do opposite side divided by the hypotenuse. Okay, cosine is the adjacent side. Obviously, I'm abbreviating opposite and adjacent over the hypotenuse. I'm going to abbreviate that. And tangent, which we're not going to talk about today really, but that function is opposite divided by adjacent side, ADJ. Okay, so long story short, this SOHCAHTOA comes into play quite a bit as we're doing even the unit circle. Let's start with sine. So sine is the opposite over the hypotenuse. Remember, our angle is being measured right here, the central angle. It's the angle that meets with the origin and the x-axis. And that particular angle, if I were to find sine of this angle, I'd be looking at the opposite side over the hypotenuse. Now, how long is this hypotenuse again? How long is this radius if we're talking about a unit circle? It's a radius of 1. So sine is going to be my opposite side divided by 1. And I just told you that the y-coordinate, sine is the y-coordinate. So because this radius is 1, whatever this number is over here, it's going to be a decimal, like let's say 0.707 for instance. That decimal is going to be my y-coordinate. Opposite side over hypotenuse. And then just similarly, my adjacent side would be my x distance out. So this point right here is y, or sine of theta units up, and this is x units, or cosine of theta units out from the origin. And that gives us the coordinates of the point here. So the big idea, again, is that cosine is your x-coordinate, sine is your y-coordinate. That'll help tremendously with everything that we're doing. So let's go on with that and talk about some of the implications. All right, first thing we need to do is probably recap a little bit the whole idea of measuring angles. So we'll start with this. When I am moving this direction, so when I'm moving counterclockwise, that's going to be a positive angle measurement. When I move this direction, I have a negative angle measurement. So let's pick an angle that's actually over here in the second quadrant. Let's pick this angle right here. That angle, let's say it is 140 degrees. Okay, so it's past 90, it's not quite to 180, it's at 140 degrees. That angle can be named actually an infinite number of things. Another name we can have for it is the angle negative 220 degrees. That angle is going backwards. These two combined should make 360 degrees if we make this one positive, because they make a full circle if I were to take all of this one that's covered and all of this one. All right, so we have two different angle names there. Now I can take each of those and add an extra 360 degrees, and now, or subtract an extra 360 degrees, now I have another angle that's the same, has the same what we call terminal side. Okay, its terminal side just means basically the radius where our angle stops. So 140 was great, but I actually could have an angle called, and this is going to get a little messy, sorry about this. So it's going all the way around, and then it's going to here. That angle would be called 500 degrees. 140 degrees plus another 360 degrees. Likewise, I could go backwards a full rotation and then end back where this negative 220 is, and that would be a negative 360 onto there, so that'd be a negative 580.